Hi, my name is Jack Cochran. I work for VUV Analytics. We make vacuum ultraviolet spectrometers for gas chromatography. And today, in our first installment of applications briefs, I want to talk to you about residual solvents analysis. Residual solvents analysis is something that the pharmaceutical industry does because of the fact that they don't want residual solvents in their products because those have some toxicity associated with them. And what I want to tell you about today is a way that we actually help the pharma industry increase throughput by gas chromatographic compression and combination of Class 1 and Class 2 solvents analysis in one analytical run. To do this, we use our vacuum ultraviolet spectrometer as a detector for gas chromatography, coupled with a static headspace autosampler from Gerstel called the MPS2 that takes care of all the sample preparation for us in a very automated fashion to make it very reproducible. One of the reasons we took on the residual solvents work is that we knew we could take advantage of our detection system, the VGA100, to actually help us compress the gas chromatography. In traditional USP methods, they use flame ionization detection, which is a non-specific detector, and you're obligated to chromatographically separate everything. With the spectrometer, you're not obligated to do that, and so you can actually deconvolve things, and that allows you a lot of leeway on the analytical run times. Typical USP run times are in the neighborhood of 60 minutes, and we knew we could do substantially better than that, even dividing it by half or even more. Ultimately, what we ended up with was a run time of about 8 minutes. And we actually got the Class 1 and the Class 2 residual solvents together in this case, which is a relatively good achievement, we think. And again, it's because of the fact that we can do deconvolution techniques to resolve these things, if you will, and we're not solely relying on the gas chromatography. Now, one of the things that's very important when you propose to combine the Class 1 and Class 2 residual solvents is that you can actually hit the desired concentration limits. Class 1s are things that never get used, or mostly never get used, in the pharmaceutical industry because they're relatively toxic. They have low concentration limits. Benzene, for example, has a concentration limit of 2 ppm. And on the other end, for the Class 2s, you actually run into several thousands of ppm. So you also have to have good dynamic range in a detector when you propose to do these things together, and we definitely have that with the VGA100. Finally, you can't do any of this without having a very powerful static headspace autosampler. And we rely on the Gerstel MPS2 in our case, and that actually helps with the analytical throughput also. One of the ways it does this is we have a mixing box here, an incubation box, that provides heat and a stirring action. Not all static headspace autosamplers actually provide the stirring capability, and that helps us speed up the equilibration process quite a bit so we can match that nicely with the fast GC VUV approach. So we're quite happy to have the Gerstel MPS2 involved in the whole thing. I mentioned earlier that we use the Gerstel MPS2 autosampler for the static headspace work that we're doing with residual solvents. And this is very important because it actually allows a faster equilibration time so that we can match that with the fast GC VUV that we're doing for residual solvents and pharma work to increase throughput. The Gerstel system actually employs shaking in heat to do the equilibration, where not all static headspace autosamplers do that. This shaking combined with the heat results in a fast equilibration time that matches very well with the analytical runtime. Okay, what we're looking at here on this particular slide is our preliminary results for chromatographic compression. We use Class 2 residual solvents and an example excipient, citric acid, and you can already see that the runtime is very short, 8 minutes total with tetraline, the last eluting solvent eluting at about 7 minutes. You can also see close to the start of the chromatogram a very nice peak for water, which we typically don't see when we're using flame ionization detection for analysis of residual solvents. That opens the door potentially to water determination in some pharma products, the fact that we can chromatograph it very nicely and also detect it with VUV. What you're looking at right here is the fast GC VUV of residual solvents in an example pharma product, in this case throat spray. Now these are residual solvents that we actually spiked into the throat spray, and you're seeing the chromatogram occur live, and you're also, if you're looking at the bottom of the screen, seeing absorbance spectra appear as the residual solvents that were spiked into the throat spray elute. And hopefully what you're noticing is the chromatogram goes along as the peaks are very narrow. This is very fast gas chromatography. The goal here, of course, is to increase analytical throughput so we can do more samples per day. I hope you enjoyed this short introduction to residual solvents analysis using the Gerstel MPS2 static headspace autosampler with fast GC and our VGA 100 VUV detector. If you like what you saw here, go to our website, vuvanalytics.com, and check out our application notes and blog. Also, don't forget we have an upcoming LCGC webinar that will be given by my colleague Lindsay Shear, who has done more in-depth work on residual solvents analysis. Thank you.